Good morning, everyone. So myself, Priya RK, and I am a top educator in EAMCET category for TS and AP. I have 4 years of teaching experience in CET, JEE, and as well as NEET. You can go for this plus subscription and use the code PRKLIVE in order to get 10% off on the different plans that are available. We have 12 months plan for 12,375. 6 months plan is available for 10,125, and there is also 1 month trial price which is about 2,250. So if you wish to get 10% off on this pricing, you can use the code PRKLIVE in order to get premium content at very affordable price, and live courses will be there. Classes will be conducted 24/7. Live quiz will be there. Separate batch for all the type of students. Then the test may also include TPPs, and you can have unlimited access from a single subscription. So let me just see who all are there. Good morning, Ashish. Good morning, Sudham. Yeah, good number of students. Fine. Good morning, Komala. Thank you so much for joining. Please subscribe to my channel on Unacademy also, and you can watch many classes over there for second year, for first year, also for the regular theory batch. Okay, yeah. So we'll just wait for 1 minute. Yes. So today we are going to have a brief discussion on what all important topics are there from chemical kinetics. What you need to know for your examination from the point of chemical kinetics. Okay, important formulas and small tricks in order to have a good speed of solving questions. Okay, yes, Komala will start up now. Great. So, chemical kinetics, let me just give you a brief introduction. It is the study of speed of any chemical reaction. Okay, but here we do not take this word speed. We don't say that the word speed. What we take? We take the word that is rate. Okay, study of rate of chemical reaction is known as chemical kinetics. Now, what is this study of rate of chemical reaction? It means whether a reaction is going faster, whether a reaction is going very slow, or whether a reaction is moderate. To know the speed of this particular reaction, we usually study it under chemical kinetics, and it is known as rate of any chemical reaction. Right. Now, there are different factors which would affect the rate of any chemical reaction. For example, first factor that is affecting the speed or rate of any chemical reaction is concentration of the reactant. Concentration of the reactant. We can say rate of any chemical reaction is directly proportional to concentration of the reactant. Then it also depends on the physical state of the reactant. The physical state of the reactant. If you take gaseous, liquid and solids reactants, among this the most easily available reactant for faster reaction is the gaseous molecules. And also, as the surface area of the reactant increases, the rate of the reaction also increases. Third one, the temperature at which the reaction is taking place. The temperature at which the reaction takes place is also very important. Good morning, Preeti. Good morning, Prathamesh. Thank you so much for joining. Please stay tuned. Yeah. Then, presence of catalyst. So we know that if you want to make any reaction to speed up or increase its rate, then what we add is a substance known as catalyst. Now what is function of catalyst? Catalyst is any substance that increase the rate of reaction. And one more thing, it is not consumed in the entire reaction. It will be regenerated after the reaction is completed. So even the catalyst activity can be increased. So can anyone tell me in the comment section or chat box, like, what substance increases the further activity of a catalyst? Which substance further increases the activity of a catalyst? You can comment in the comment section. Okay, right answer, Shrishil. It is the promoter. The promoter increases the activity of the catalyst. Right. Now coming to specific different formulas from this particular chapter. So here we are going to learn about chemical kinetics in just one shot. Means in just one class. What all is important. So important formula from here is reaction rate. How can we express the rate of any particular reaction? Now, rate of any chemical reaction is change in the concentration of the reactant or the product in certain time t. Now, this concentration can be expressed as mole per liter and time can be expressed in seconds, minutes or hours. So, what we say, rate of any chemical reaction is the change in the concentration of the reactant or change in the concentration of the product. Now, this can be even mathematically represented like this. Rate of a reaction is equals to change in concentration divided by change in time. How much the concentration is changing in that particular given amount of time is known as rate of any particular reaction. Now, here we have said change in concentration of the reactant. So, you can comment in the chat section whether the concentration of the reactant decreases or it increases. Concentration of reactant, whether it decreases or increases. I'm waiting for your replies in the comment section. Okay. So there is a time lag, a little like 2 seconds or 3 seconds of time lag will be there definitely. So I understand by the time your answer reaches me, it will be some 20 seconds late. Yeah, most of you have given right answer. So right answer is it decreases. The concentration of the reactant decreases with time. And what about concentration of the product? Concentration of product, whether it increases or it decreases with time. Whether concentration of product increase or decrease with time. Right answer, Jadhav, Shafakat, Saubhagya, Sanjana, very good. Good all of you, Bhagyashri, Preeti, Shrishel. Okay, definitely with time, the concentration of the product will increase. Okay, so how can we express this? Now let us take, there is a reactant A and there it is forming a product B. Now this rate is what? Rate is change in the concentration upon change in time, right? Now let us see for reactant. Just now we have discussed that the change in concentration of the reactant, how it is? It decreases, right? Therefore, what we can say, rate is equals to change, means if I take this as delta concentration of A, means the concentration change, final concentration minus initial concentration upon time T. Now here the concentration of the reactant is decreasing, right? As the concentration of reactant decreases, what we take here is a negative sign. Why I have marked here? Because you should not go wrong. Because always the concentration of the reactant decreases, we have to always use negative sign here while writing the rate of any particular reaction. So rate is equals to delta concentration of A. This square bracket always represents what? Concentration. So instead of writing concentration all the time, what you can take? You can just take this square bracket. So rate is equals to minus delta concentration of A upon delta T, change in time T. Now coming to rate of the product. Rate of product. As we know, concentration of the products are increasing. Therefore, rate will be positive for the product. Whatever rate you write, it will be positive for the product from the product side. Therefore, change in concentration of B divided by change in time T. Therefore, this, because concentration of A decreases with time, therefore delta A is negative. This you can remember. Okay, right. Now, let us take this A as the reactant, B as the product. Now here all these reactants, so specifically it has been marked that A is the black color molecules and B are the red color molecules, that are the products. So here the time clock you can see. So as the time increases, concentration of the reactant, initially it was very high, all the black color molecules you can see, and here you can see the red color molecules. So as the time goes on increasing, the concentration of the reactants have decreased, whereas the concentration of the products, that are the red colored molecules, they have increased. So all of you understood this? Yeah, you can let me know in the comment section. Yes, okay. So with increase in time, we can say concentration of A decreases, that is the reactant decreases, and concentration of the product molecules, they increase. So with the time, concentration of A decreases. We can see it through graph as well. And concentration of the reactants decreases, concentration of the product B molecules increases. Okay, now let us take one equation. N2 plus 3H2 gives 2NH3. Okay, can anyone comment which reaction it is? Can anyone tell me which reaction it is? What is the name of this particular reaction? You can comment in the comment section. Okay, so someone has commented. Right. So definitely this is Born-Haber process of synthesis of ammonia. Now if I want to express or write the rate of this particular reaction, then how I can write? So the rate can, yes, right answer Shrishel. The right answer for this would be, we have to consider the stoichiometric coefficients here. So here nothing is there means definitely 1 is there. Here stoichiometric coefficient is 3. Here stoichiometric coefficient is 2. So how to express the rate of this particular reaction? So these two are the reactants. This is the product. So what I can write? Minus 1 upon whatever stoichiometric coefficient is here. So nothing is there means 1 is there. I can write it as 1 directly. D, or you can write delta. Concentration of N2 upon dt is equal to minus 1 upon whatever stoichiometric coefficient is there here. Minus 1 by 3 d concentration of H2 upon dt is equals to, now this is the product, plus 1 upon 2 d concentration of NH3 upon dt. Now what is the meaning of all this? So this 1 upon 1 I can just write it as minus d concentration of N2 upon dt is equals to minus 1 by 3 d concentration of H2 upon dt is equals to plus 1 upon 2 d concentration of NH3 upon dt. So what we can say is, rate of change or rate of decrease in concentration, rate of decrease in concentration of reactant is equal to rate of increase in concentration of product. That's the meaning, right? Rate of decrease in concentration of the reactant is equal to rate of increase in the concentration of the product. And this is true. This is true for all the reactions. Okay. So you should be able to just write this type of rate equation. Okay. Moving on to the rate law. Now rate law actually gives you a relationship between rate of a reaction to the rate constant and also to the concentration of the reactants. So what is this rate law? Let us just generally consider a reaction AA plus BB gives CC plus DD. A and B are the reactants, C and D they are the products. Now this A, B, C and D, these are the stoichiometric coefficient in the balanced chemical equation, right? Okay, now what is rate law? Rate of any reaction is proportional to, okay, rate of any reaction is proportional to concentration of the reactant raised to certain power. Okay, so based on that, let us try to write the mathematical equation. Rate is equals to, or else you can just take according to the equation, rate is proportional to concentration of the reactant raised to some powers. Raised to some powers. So if you want to remove this proportionality sign, what you can take? Equal to and a constant k. Okay, and a constant k. So now your rate will be equal to k concentration of A raised to x, B raised to y. Now what are this x and y? This x and y may or may not be equal to A and B. Okay, they may or may not be equal to the stoichiometric coefficients of the balanced chemical equation, right? So this is how we write a rate equation. Rate is equals to K into concentration of the reactant raised to certain power. Here we have taken x and y. This x and y may be equal to this small a and b, or they may not be equal to small a and b. So reaction is, now what is this value x and y? These x and y, they will usually tell us the order of the reaction. Now what is order of the reaction? We'll see it in detail. So here we say A is xth order. Okay, A is xth order while B is yth order of the reaction. Therefore, how can we say order of any reaction? Order of the reaction is sum of the powers. Sum of the powers. Simply, sum of the powers is known as order of any particular reaction. Okay. Now, what this order or rate expression they generally tell us. Now, for example, we have x plus y giving rise to some product z. Okay, giving rise to certain product z. Now, this x and y both are reactants. Now, how can we say that both are contributing equal to the formation of z? Maybe x is contributing more, maybe y is contributing more, or both of them may be contributing equally. So how to know this? This is completely experimental data which we need to find through experiments. Okay, so maybe x is contributing more or maybe y is contributing more for the formation of z. So this can be known through order of a particular reaction. Okay, now let us look at any particular chemical equation. X plus y gives z. X plus y, it is giving z. Okay, now how can I write rate of this particular reaction? Rate is equals to k x raised to whatever power is there. So as I said, it may be or may not be equal to the stoichiometric coefficient, right? It may be or may not be equal to the stoichiometric coefficient. So if you just see here, what we have 1 here. But if you see here in the rate equation, they have given rate is equals to k x raised to 1 y raised to 2 they have written, right? They have said rate is equals to k x raised to 1 y raised to 2. That means if I take a and b here and x and y here, then they are not equal. They are not equal here. So order of any particular reaction tells us what is the particular contribution of that particular reactant in the given reaction. And how to calculate the order? Order is the sum of powers. For example, if you just come here, the overall reaction order of x plus y is, here nothing is there means 1 is there, 1 plus 2. That means it is a third order reaction. It is a third order reaction. Okay. So this is again what is the rate expression. Rate is equals to k x raised to m y raised to n. The overall of the order of the reaction can be given by m plus n. That is the powers. Okay. Now how to calculate units of a particular rate constant? So we know rate is equals to k. Let us take, there is a reaction, A gives B. So your reactant is A. So rate is equals to k into concentration of A. We want to find the rate of this particular k. X raised to m y. We need to find the rate of this unit of this particular k, rate constant, right? Rate, you know, it is mole per liter per second, right? Okay, then k we can write. Then concentration unit is mole per liter or mole per dm cube. Mole per liter get cancelled. Your unit for first order reaction, that is concentration raised to 1, right? That is your first order reaction, will be second inverse. Next, coming to second order reaction. Rate is equals to k concentration of A, concentration of B. Here it is second order because A raised to 1, B raised to 1. If you add this, order of this particular reaction is 1 plus 1, that is equals to 2. Rate we know, mole per liter per second, and K we need to find the unit of, then concentration of A, mole per liter or mole per dm cube, concentration of B, mole per dm cube. So 1 mole per dm cube, 1 mole per dm cube gets cancelled. Then this mole per dm cube, if you bring on the other side, it will be mole inverse dm cube second inverse, right? Okay. Now how to generally find the unit of any particular reaction. So every time it goes difficult, right, to remember every reaction and to say whether it is first order reactions unit or second order reactions unit or any other particular order reactions unit. So how to generally find the unit of any particular reaction? So what we can do here is we have an expression which generally tells us how we can actually calculate unit of any particular reaction. So let me just write it on the screen. What is the unit of any particular reaction and how it can be done? Okay. So first basically what we should know here is what is the unit for concentration. If you know the unit for concentration, then generally for any reaction, K, rate constant, is equals to rate upon concentration of A raised to X, concentration of B raised to Y, right? So rate, what is the unit? Concentration by time, right? Rate. Okay. And this is a concentration, right? So I can write 1 upon concentration raised to N. So this is general equation. So where N is equals to order of any particular reaction, where N is equals to order of any particular reaction. Therefore, how can we even calculate it for zero order reaction? How can we calculate it for zero order reaction? Let us just see here calculation for a zero order reaction. First and second order we just saw. Let us use this equation for zero order reaction. What is a zero order reaction? A reaction in which rate is proportional to zeroth power of the reactant. Zeroth power of the reactant. Okay. Therefore, for zero order reaction, what I can write? Concentration, mole per liter, right? Time is seconds into 1 upon concentration. Unit of concentration is mole per liter raised to 0, because what is the order of this reaction? Zero order reaction. Anything raised to 0 is 1. Therefore, this will be mole per liter per second. Okay, mole per liter per second. So that is the meaning of calculation of order of any particular reaction. Okay, and its unit. Now coming to very important concept, that is what we call it as integrated rate equations. Now integrated rate equations are generally very confusing, but I'll make it easy for you people by giving it at a particular stretch, okay, so that whenever we have any such equation we can directly do it. So let us go for integrated rate equation of a zero order reaction. So here A is getting converted into product. Some reactant A is getting converted into product. Okay, let us consider it in this manner. Okay, now for zero order reaction we have AT, that is concentration of the reactant. You can take it as R also, no issues. If you are comfortable with that, we'll take it as R, no problem. initial concentration is represented by R naught and final concentration is represented by R. So RT and is equals to R naught minus K into T. Final concentration is equals to initial concentration minus KT. This is your zero order reaction equation. Now this we can equate to the straight line equation. Y is equals to C plus mx, right? Now usually this C value, whichever you have, it will act as your intercept. It will be your intercept. This will be your y-axis as usual. Your x will be your x-axis and your m will be your slope, right? Okay. Now how to draw a graph from this? How to draw a graph from this? So let us take, using the straight line equation, we can draw a graph of this. So on y-axis what we have? Concentration of R at certain time t. Then on x-axis what we have? Time. Okay. Then what is your slope? Minus k. Minus k means definitely the graph should come down. So your slope for this graph is minus k. And what is your intercept here? Your intercept is concentration of R naught. So this is the graph for zero order reaction. Okay. Likewise, for first order reaction, what is our integrated rate law? Ln concentration of A at certain time t, A, or you can take it as R. Ln concentration of R naught minus KT. Again equate it to the straight line equation. Y is equals to C m into x. Right? Now coming to the graph of this particular equation. Again on y-axis what we have? Ln concentration of RT. On x-axis we have time t. And slope, again we have negative slope minus k. So slope is equals to minus k. And intercept, here your intercept is ln R naught. Okay. So from this equation, if you integrate it, what you have got? We have got k is equals to 2.303 upon t, log of AT upon log of, sorry, A naught upon, that is R naught, your R naught upon log of R. Okay. So this is the integrated rate equation, log of R naught upon R, right, at certain time t. This is your first order reaction. Okay. Now coming to second order reaction. Second order reaction, what equation we have? 1 upon concentration of R at time t is equals to 1 upon concentration of R naught upon plus K into T. Again, Y is equals to C into mx. If I draw a graph of this, y-axis, we have 1 upon concentration of RT here on the y-axis. On x-axis, we have time t. Then again, slope is positive here. So slope positive means it should come from like this. So slope is equals to plus k, right? And your intercept value is 1 upon R naught. 1 upon R naught. Now, we cannot remember it for every order reaction, right? It's not possible for us to remember this rate equation for every order reaction. Then how can we usually do it? This can be generalized. Okay, this can be generalized, and we can have a general equation. How we have for the units. So general formula for integrated rate equation is 1 upon concentration of A at time t raised to 1 minus n minus 1, where n is order of the reaction, is equals to 1 upon concentration of A naught n minus 1 plus n minus 1 K into T. Here n is order of the particular reaction. Okay, this is the general formula where you can write integrated rate law of any order reaction except for first order. Except for first order, this is applicable. Okay, this formula is applicable for all the order of reactions except for the first order reaction. Okay, yeah. So that's the general equation we have studied. That is 1 upon concentration of A T n minus 1 is equals to 1 upon concentration of A naught. Some people take it as A or R, whatever you can feel like. Okay, plus n minus 1 K into T. This equation is not applicable to first order reaction. Okay, whereas you can find for any other order reaction. Now this is the summary for all the different formulas that we have studied so far. And for zero order reaction, rate is equals to K concentration of A raised to 0. A raised to 0 is again nothing but 1. So we can write a rate is equals to K. Integrated rate equation, A is equals to A naught minus KT. T half. T half of any reaction is the time at which half of the initial concentration is consumed. So this is the equation for that. Then for first order reaction, rate is proportional to first power of the concentration of reactant. For second order reaction, rate is proportional to second power of the initial concentration of the reactant, right? So integrated rate law for first order is ln A is equals to ln A naught minus KT. T half is ln 2 upon K. This can be written as 0.693 upon K also, right? And here you have T half is equals to 1 upon A naught. 1 upon A naught, right? So if you have any doubts, you can ask me. If anyone has a doubt, you can ask me. Good morning, Ebert, Pawan, Sayam, Apurva, Purna, Nakul. Thank you so much for joining, all of you. You can just subscribe to this channel and please watch the live sessions, right? So my next live session is on 16th. Okay, my next YouTube live session is on 16th of this month at 9 a.m. That is on solid state. Okay, so one shot we would be studying about the solid state particular chapter. So please again come back live on this platform where you can subscribe to this particular channel in order to get the notification. And as I am telling you that my next live session will be on 16th of this particular month, again at 9 a.m. The topic would be solid state. So thank you so much everyone for joining for the class, and hope to see you for the next live session as well. So thank you everyone.